All right, so we're starting session 2 of lesson 4. The objective this time is a little bit different. It is students will be able to identify similar figures using corresponding sides and angles. Now, we already talked about what similar means in session 1, but we're going to go ahead and define it again because it's new and it's a really big idea that we're going to try to understand in this unit. So there is a special symbol that we use for similar. It's just the little squiggly line. So if that were congruent, the equal sign would go under it. But for similar, it's just that. Now, in order for two shapes to be similar, two things have to be true. The first is corresponding sides. Actually, let's start with angles. Corresponding angles are congruent. So the angles need to be exactly the same in similar figures. The second thing that needs to be true is that the corresponding sides are proportional. So if you remember, that means they're all going to reduce down to the same fraction. The second and last kind of vocab term for today is the center of dilation. Now, usually they just tell us and show us where the center of dilation is, but sometimes we have to figure out where it goes and draw it in ourselves. I don't have a definition, but I do have like a visual I want to show you for trying to figure out where it is. So let's say there's 3 different kinds. The first kind of center of dilation is when it's inside the preimage. So inside the preimage. And so say you have a figure and you have another figure, say dilated around it. It doesn't matter which one's the preimage. It could be the big one or the small one. But when it looks like this, one inside the other, the center of dilation is right in the center of both of them. So that's what it looks like if it's inside. If it is on the preimage, so say you have one of your shapes that looks like this, and the second shape looks like that. So they're connected, and this vertex that they have in common, that is the center of dilation. The last way is if it is outside the preimage. So this can look 2 different ways. You might have one shape like this and the other overlaps it. The center of dilation would be around here somewhere. Or the shapes might not be touching at all. So they're 2 separate shapes. I'm not sure. I think the center of dilation is over here somewhere. So it can be inside, it can be on, or it can be outside. So those are the notes. And now we're going to do 2 examples of how to prove 2 shapes are similar.